Guys, I am sick of it using incandescent light bulbs as a dummy load for electronic experimenting. So I think now it's definitely time to build a proper electronic dummy load. I want to have a electronic dummy load with two settings, and the high and the low one. And let's start off with building the high power resistor. Yes, the resistor is finished and it shows me about 1 ohm, which is perfectly fine because with the transistors and all the wirings I will end up with about 2 to 3 ohms, so that's fine. And I put some paint on it. Yeah, power resistor finished. Next step is to build a circuit, and it will be a very simple PWM circuit based on a 555 timer. And so that's the next step, to build the circuit board. So I'm starting off with my stable power supply here. So the DC voltage comes in here, goes through a reverse polarity protection diode and a fuse to a voltage regulator. This gives me 12 volt stabilized, so that's the first step. Pin 8 and pin 4 goes to VCC. The 1K resistor and the 2 diodes. The circuit is done. Let's test it. So the PWM controller is working. Here is my 555 timer, the capacitors, a fuse here. Here is my potentiometer. This will lead to the gates of the power transistors, and meanwhile I also added a fan speed controller circuit. Here is this NTC thermistor to control the speed according to the temperature of the resistor. And I also added a bridge rectifier and a smoothing capacitor because I want to drive this circuit board with an external power supply here, with this mains voltage transformer. So here is my heatsink of choice, and to mount the MOSFETs I will use the already existing holes here. So here are my 6 transistors and 1 flyback diode, just to be on the safe side. And here is a quick tip. I'm using the insulation of a silicone wire here as a heat resistant sleeve, so it will not melt during the soldering process. All the gates of the MOSFETs are connected, and now I will do the same on the drain and the source pins. So here are all my bulky parts, and now I will obviously need some kind of enclosure, and I will start off with making a base plate.
Once a day that I would pray for you, I'd go and misbehave just so you'd notice too. Sneaking looks up and down from across the room. Damn, what a hell of a view. I feel good, you look great, I like you, I can't wait. A first time, a first date, you're so fine, I'm so late. You sip wine, I drink straight, don't waste time to my place. I feel my heart erase, so catch me if I fall. Praying that this night's gonna last. You got it all on tap. I'm loving your vibe, always have your back. We like all the same tracks, listen all night in the sheets all black. Said I'm falling fast, don't remember life before you, that's fact. I feel good, you look great, I like you, I can't wait. A first time, a first date, you're so fine, I'm so late. You sip wine, I drink straight, don't waste time to my place. I feel my heart erase, so catch me if I fall.
Yo-ho! So here is the enclosure of the thingy, and as usual it is no rocket science what I'm doing here. It is just a 2 centimeter thick plywood base covered with aluminium tape, heat resistant aluminium tape, like the plumbers use it. Front and back panels are made out of steel, 1.2 millimeter steel. It was an old computer enclosure, and I added some wooden strips here to mount the top cover on, and the top cover is made out of aluminium, 0.7 millimeter aluminium, and I also mounted a handle. The idea behind this is that the cooling air enters the housing here and gets sucked through and out at the back here with this PC fan. And as you already see, I started with finding the arrangement for all the bulky parts here. Next step is to make all the cutouts here for the meters and connectors and switches, and to paint everything. Hose back! Oh, old school! Great! Now it's time for the final assembly, which I will do off camera. And I am back with a fully assembled device. I know what you say, it looks a bit cumbersome, but hey, it is built like a tank. So let me show you what I did and how I assembled everything. So here are the guts of the device. Here is the main circuit board with the 555 timer IC and all the circuitry around it. Here is the circuit for the fan controlling, the cooling fan. Here is a small mains transformer to power the electronics. Here is my big chunky homemade resistor, a 1 ohm resistor. This is the NTC. It is glued to the resistor with heat resistant silicone, and it measures the temperature of the resistor, and it regulates the cooling fan accordingly to the temperature. Here is the additional 10 ohm resistor. It gets bridged, or it can be bridged via this 40 amp relay here. That gives me two settings, a high and a low setting, which I will show you in a moment. Okay, here underneath, maybe you can see it, is another heatsink with the 6 MOSFETs, N-channel MOSFETs, and the flyback diode. Here is a voltmeter and an ammeter. Yeah, that's basically it. And here on the front we can see the terminals, and I have a wire here with a built-in fuse. Here is my power switch. You can power it on. And here is the switch for high and low setting. So the current flows via the 10 ohm resistor in the low setting and via the 1 ohm resistor in the high setting. You can red green. I can switch from high to low, and here I can adjust the pulse width of the PWM circuit to regulate the amperes going through the device. Yeah, that's basically it. An ammeter, a voltmeter. Here is the power plug, and these are the circuit diagrams. This is the diagram for the cooling fan speed controlling. It is done via a NTC, as I said, this NTC here, and here is the 555 PWM signal circuit, a very basic circuit, and it's around for a long time. And here are my MOSFET bank here, 6 MOSFETs, flyback diode, the 1 ohm resistor, the big one, and the 10 ohm resistor. This one here, the switch here, is basically the relay, ammeter, voltmeter, and the gates get their signal from the timer IC. That's it. And I will post all these circuit diagrams here on my Pinterest profile, as well as to my Patreon profile. So if you want to support me more actively, please consider to become a Patreon, and Patreon/Larifari. Yeah, it would help me a lot here in the shop. So okay, I think it is time to put the lid on and test it. Okay, so just in case you don't know what a dummy load does, here is a typical example. I have here a line voltage transformer from 230 volt AC to 12 volt AC. The AC gets rectified via this projectifier here, and the 12 volt DC feeds into my device here, and now I can burden the transformer to see how it reacts. And let's crank up the amps here, and I can already see that if I go above 2.5 amps, the voltage drops significantly. So that gives me a hint that this transformer here is probably a 2.5 amp transformer. So I'm going back here to 2.5 amps, and we have our 12 volt back. And what I'm doing next is I will leave it like it is for an hour or so, and I can feel if the transformer is getting hot or gets too hot. And that's what a dummy load does. It burdens a device or a circuit, and it can be adjusted. So it is basically a adjustable test load. Okay guys, so that wraps it up. And as usual, if you like this video, give me a thumbs up, share, subscribe, leave me a comment. You can ask me something if you want to, and if you want to support me again, you can do this via patreon.com/larifari. So please consider to give me $1 or $2, and I will post sneak peeks and pictures from upcoming projects for my patrons. What's left is to say thanks for watching, and see you soon.